Olusegun. In today's live session, we're going to, dissect a particular video by Robert Lawrence Kuhn. Robert Lawrence Kuhn of Closer to Truth. So the title of the video is What is Causation? Now this topic is so tough. It is a tough topic to handle, and this will actually make us to go deep into the nature of time, into the nature of energy, and at the end of everything we should be able to know what the true nature of relativity is. Now this question is something that we deeper into my novel research discovery. So I hope with my novel research discovery I show what causation is. Expected of me to unravel this mystery of causation, if indeed I mechanics just as I claim. We're going to see how intuitively I'll be able to do justice to this particular topic. Now I believe this video is going to be quite insightful and it's going to be informative. So I want us to go through the whole part of the video for us to have idea of what other people's opinions are on that topic, causation. So we're going to do that, and after that I will give my own opinion. So I intend to use this image video to visually illustrate and to drive home my point. Let's dive into it. So I want to so as to give enough room to the video. Okay, so now we have the video. So now let's dive into it.
What's reality? What are the most primitive things from which the universe, everything, is constructed? Energy, matter, space-time, information? Sure, but still, to understand existence, what it's all about, I need to drill deeper. And I'll remain restless until I reach the bedrock of reality. Reality is composed of events. Things happen, things change, on all levels, from the subatomic to the supragalactic. But how do things happen and change? Why is it the case that events occur? Why does one thing follow another thing? Key is the concept of cause. Why does one thing cause another thing? But some say cause is a kind of causation. I'm Robert Lawrence Kuhn, and Closer to Truth is my journey to find out. Causation is just there, obvious, even trivial, right? Causation has no need of explanation. Causation explains other things. Nothing explains it, right? Maybe not. If I seek bedrock reality, if such be possible, causation is just the sort of thing that must be explained. Science is no help. Science assumes causation, explains what causes what and how, but it is not science to explain what causation itself actually is. Causation is one of the most general features of the world. That's why, to get at it, I turn to philosophy, especially to metaphysics. I go to Cambridge, England, to begin with a distinguished British philosopher, Simon Blackburn. Simon, causation is a very fundamental way that reality is structured. How can we begin to understand the deep nature of causation?
Well, the philosophical running here was set by David Hume, writing back in the early 18th century. Hume argued two things about causation. The first was you couldn't know anything about what caused what, antecedent to experience. You had to learn about how events fall out, and that's a matter of sensory experience and just finding how they do. For example, a baby in the first 6 months or year of its life might be just finding how nature is patterned. What happens when you let go of your milk bottle? It falls to the ground. Gosh, let's do it again. And that's the way we learn about causation. The second very important thing was that there's a sense in which causation doesn't hit the eye in the same way that, for example, colors do, or shapes or sounds hit the ear. We see what does happen, but we don't see that one event must cause another one to happen. Now, causation has this sort of must happen. If you throw the baseball through the window, the window will break. It must break. And it's that aspect of necessity which Hume thought was very, very important to causation, but which isn't given to the senses. We see the window break. We see it happen again and again, we get very used to it, but we don't see that the window must break. Hume derived from this the idea that actually the must is something that we impose. So causation is very much our own kind of mind reading its own habits or customs into the world. So we see events as if they're connected by these necessities than in the events. So Hume's conception of the world then becomes a very atomistic conception in the sense that it's just individual events, one happening after another, and us imposing a causal order on what we see or hear or take from the world. And that's been controversial ever since because it and puts it back in our own minds.
So what is the relationship then between way and the concept of physical laws?
Well, very close, of course, because probably our first examples of physical laws would probably be causal laws. Take, say, the law of gravitational attraction in Newtonian physics. Bodies must attract each other with a force inversely proportional to the square of the distance between them. That's a causal law, and yet it's very hard to know in what the existence of that law consists, what kind of reality answers to that law. And Hume would again say, well, the only reality is that that's how events fall out. That's what your measurements will give you. It's a pattern, but it's not an explanation of the pattern.
So to understand causation is how important in understanding our world?
Well, I think we'd be very baffled, we are very baffled when we find things for which we can offer no causal explanation. Finding the regularities, the way things fall out, is of course integral to any scientific understanding of the world. I think the human mind is shaped that way. So, for example, in more primitive times, people looked at agency causation. They felt they understood themselves doing things. So if you've got agents doing things, that somehow explains things nicely.
Spirits and gods and souls.
Exactly. Now, of course, with the rise of modern science, we felt that we were on firmer ground saying how things cause things. And agency causation slipped back in the running, as it were. If Hume is right, all we're doing is putting things into more and more elaborate patterns. And if we go on asking what's the rationale for those patterns, we're eventually going to meet a blank wall. Now, of course, we'd like to understand causation, so we understand why things must happen as they do. But that may be a goal that we can't achieve.
To Simon, causation is patterns composed by the human mind in response to regularities in nature. To go much deeper, he says, is not possible. Simon's causation is minimalist, a human construct. We read causation into reality. He says it's not a feature of reality itself. This could make sense, particularly if the physical world is all there is. Simon is an atheistic philosopher. I wonder whether a theistic philosopher would invest causation with greater inherent powers. I go to Oxford to meet a distinguished philosopher of religion, Richard Swinburne.
There are different theories of causation around. One very fashionable theory is due to Hume. According to Hume, causation depends on laws of nature, and according to this account, laws of nature are just the regularities of things. It's a pattern of events. Now, I think this is a mistaken account. I think the notion of causation is a basic one, and it cannot be analyzed in terms of anything else. And my reason for this is that we ourselves cause things, and our own causing. There's a distinction between basic actions and non-basic actions. Non-basic action is one which I do by doing a basic action. For example, if I pull a gun at somebody and shoot them, I shoot them by firing a gun at them. I fire the gun at them by pulling a trigger. I pull a trigger by squeezing my finger. But when you come to the action that I don't do by anything else, that's a basic action. The other's a non-basic action. Now, what is it to do a basic action? It's just to do the action. I don't do one action and hope it'll be followed by the motion of my hand. There's no further action which I do. There is just causing. That's all there is. So that suggests that causing can't always be analyzed in terms of exemplifying a regularity. And if that's right in this case, let's go back and see if we can't analyze causing in the case in the inanimate world where it does exemplify a laws of nature also in this way. And I think we can. In ancient and medieval times, people didn't think of laws of nature. They just thought of individual things, such as the earth, having certain powers, e.g. to attract objects. Therefore, they thought of causation as exercised by things, by substances, by the earth. And that makes it more and more similar to when I move my hand, the causation is exemplified by me. The difference is that when I do an action, I exemplify the causation by intentionally trying to bring the effect about. Whereas when the earth attracts a stone, the earth has causation in terms of laws of nature, but you can analyze laws of nature in terms of causation. Laws of nature just are the causal regularities.
What are the implications of that? Some would say that you can analyze causation within the universe, but you can't analyze causation about the universe.
Well, people used to say that just because they thought that causation was a matter of exemplifying regularities. But once you've got rid of that idea, it's possible that there may be causation which doesn't exemplify regularities, singular causation. And to say that God caused the universe is to say that God has certain, though he doesn't choose it to exercise on any other occasion. So the way is open, as it always was open in ancient and medieval times, to postulate a singular cause which isn't of a kind.
To Richard, causation is a fundamental principle of reality. It is not dependent on regularities, patterns, laws, or anything else. No surprise that Richard's more potent causation gives God easy entry into the world. By grounding causation as bedrock reality, a theist enables God to create the universe, sustain the universe, and even intervene in the universe. Assuming causation does mediate universal events, what are its non-theological implications? I ask a professor of metaphysics and agnostic, Robin Lepoitvan.
Philosophers have tried to offer different analyses of what causation is. So the idea behind each of these is that causation is a problematic concept. We need to explain it in terms of something that we're more familiar with. So can we explain causation in terms of regularities in nature? Can we explain causation in terms of probability, that causes make their effects more probable? Can we explain it in terms of counterfactuals? If I hadn't thrown my cigarette butt onto the petrol, there wouldn't have been an explosion of that sort. My own view is that none of these analyses is entirely workable, because one thing that an account of causation must do is to explain its asymmetry, that if A causes B, B does not cause A. And the trouble with most of the proposed analyses of causation is that they don't explain that asymmetry. So I'm tempted by the view that causation is a primitive concept. And what I mean by that is it's something that can't be explained in terms of other concepts. I think features of causation can explain features that we commonly attribute to time, for example.
How would that work?
Well, one defining feature of time is its direction. It runs from earlier to later. So what is the difference between earlier and later? I think it's a causal difference. I think what we call earlier is defined in causal terms. I think it's true that causes occur earlier than their effects, not simply accidentally, but because that's what the earlier than relation is. It's essentially a causal relation.
And some physicists actually bring in backward causation, where something in the future can cause something in the past. Does any of that make philosophical sense?
Well, it doesn't make philosophical sense if you define the direction of time in terms of the direction of causation. Backwards causation would be ruled out a priori.
Well, backwards causation in the quantum world seems to be experimentally verified. Does that trouble you?
It certainly would, if it's genuine causation rather than certain kinds of pattern.
How important, then, is causation if you build philosophical schemes?
I suggested that causation is a primitive concept, so one may explain what other phenomena it's connected with, what things you might define in terms of it, but you're not going to analyze it in terms of something in your conception of reality. I think what we...
Robin, too, will not reduce causation to human perceptions of natural regularities. Robin, remember, is agnostic, not a theist, and his maximalist causation...
Okay, that's it. We have it. So now basically, okay, so now it is now time for my own opinion on this particular video. Well, the first person that Robert Lawrence interviewed, Simon, to him, causation is a mere pattern which, was imposed by humans' idea. Well, the second person, to him, causation is a kind of fundamental phenomenon which, can be used to explain things, but not other things can actually be used to explain it. You understand? And the third person too was like trying to share part of the idea of the second person, that we can use causation to explain, for instance, the law of nature. We can say law of nature is causal. Law of nature is causal, but we can't say. So we can't say otherwise, just according to these people. But basically, what I want to the first thing I want to iron out is that by going deep or deeper or deeply into this particular topic, we're going to get what the true nature of relativity is. And so the first question I want to ask, based on if you are conversant with my videos, you know that I've been saying that time has two identities, then energy has two identities. So I'm going to now time, then when time is in relativistic scaling to energy, it becomes continuous. Now the question I now want to ask myself, is if by default time is instant, what causes time to be continuous? That is one question that I need to provide answer to in this video. Now the second question is, dealing with time, it becomes discrete. Then what makes energy? What makes energy to be discrete? That's another question that I need to answer. By answering this question, then we'll be able to have an idea of what causation is. So now I want to increase yes, this is the diagram that I want to use. I really want us to have, it's highly essential for us to have visual representation of what I want to discuss in this video, so as not to make it so worrisome or boring. You understand? So now, energy. So time is being affected by the infinite. Energy is infinite rather by default, but when in relativistic scaling with time, then it becomes discrete. Now we know that there is nothing that could have influenced the status of energy than time. So that instant nature of time has domineering power over energy, and as such we have energy to be discrete. By that, from these we can get to know the reason we have expansion in the universe and the reason we have contraction. There is this expanding phase, the black hole. So based on this, ask me that what causes time to be instant? That's another big problem. What causes time to be instant? And then what causes, you understand? But now what I can say about this is that it seems, time has this nature of being precise, and energy has this nature of being biased. So I would say basically, we have these two things. The way AI is able to actually learn, then that it's as a result of the mass worth and then the bias value. So basically, when there is this convergence to cause mass formation, of course there will be an equal reaction of that, which is going to be an inverse of such action. So that inverse of the real mass worth convergence is the energy density. So whenever basically that is what the whole essence of universe is all about, and so we will go deep into it. So now we're going to go deep into the architecture. Yes, we know that once we know the direction of energy, we know that the inverse trajectory of that energy's trajectory will be the trajectory of time. So low energy state. So definitely, time will often be at high energy state, just as we have it. So now, when you look in time to be continuous, then time causing energy to be discrete, then there is going to be this shifted perspective. There is going to be this probability. Should I say bias or biasness, if there is anything like such. So now there is this battle, and once we have this interaction, can we now really have that instant phenomenon of time, and then can we actually have that infinite phenomenon of energy? So please stay with me on this. We're going to get to the point where we'll be able to go deep into this to know if there is possibility for us to have the infinite default nature of energy and then the instant default nature of time. So now, by having that relationship, then we know that basically there is going to be this shift, there is going to be this imbalance between the interactions, such as to have suspension. So there is not going to be precise exhaustion of energy, and then there is not going to be a precise derivation of time as being instant. So basically, what will that be? What effect will that be on time? And what effect will that be on energy? So now, by that relationship, now I want us to look at the formula that we have right here, which is the T, the M equal to capital M plus 4M. This formula is formula of everything, and I call it FOE by abbreviation. This is the formula that by God's grace I developed, and this is the formula that I have. The derivation was done in my first research publication on a peer-reviewed journal, which was titled "The Time Theory of the Universe." So when you get that research publication, you can get the derivation of this formula right there. And there is another publication, which is the second publication. So I have it on that same peer-reviewed journal, and that one is titled "Seeing the Anatomy of Quantum Gravity Through Formula of Everything." So right now, let's look at this diagram. The diagram that we have here is what is known as time energy wave model. I want to shrink this a little bit so that we can actually see the full image. So now, this red trajectory is the trajectory of energy. The curvature that we have here is the curvature of energy, and then the trajectory curvature, or the trajectory that we have inversely related to that energy's trajectory, that is the trajectory of time. Now, when you look at the formula, the TDM will certainly give us curvature. And the reason we use the M is that mass is an emergent virtue that will actually, allow us to have the curvature of time trajectory and energy trajectory. So basically, by default, we're going to have energy trajectory being inversely related to time trajectory to emerge the convergence of mass worth in the universe. And so with that dt dm, you know that we're going to have capital Um plus 4M, curvature of time. This diagram, as we have it being emerged as a result of the application of this formula of everything. So everything as you have it in this time energy wave model, everything is derived, everything is actually everything is gotten by the application of the formula of everything. So I want to increase this more so that we can, see everything quite all right. So now, the whole thing is that for us to apply the formula of everything, when you put the mass worth of electron, if that is what we know, basically the formula is structured in such a way that classical mass worth is what you supply to confirm the quantum counterpart. And as well, you can use the quantum mass, to get the classical counterpart. So now, if electron is what you know, and then you want to get what the corresponding classical mass worth would be, you put the value of electron, say 9.109 times 10 raised to power minus 31 kilogram. And then by applying this formula, we're going to get the classical mass worth of that electron to be 2,277,250,000 kilograms. That is what we have inside the equilateral triangle. Now, the triangle that we have right inside the curvature of time to energy, that is equilateral triangle. So now, if we now want to use this classical mass worth to reconfirm the quantum electrons worth, we put that value right inside in the place of 2m's of the formula, and then what we get is different because this trajectory of time, we can only traverse it one time. It's a one-way traffic. So since we have used the value of electron to get the classical counterpart's value, which is 2,277,250,000 kilograms, we have traversed. And so our grace of getting to know the actual counterpart value at classical level is being exhausted at that first trip. So by using the classical mass worth to reconfirm that electron's value, and so now by supplying the classical mass worth, what we now get is 9.109 times 10 raised to power minus 32. You can see that 32 is smaller compared to 31, and so we know that we already have decay effect on it. And what that is telling us is that that trajectory is being shifted into the future. And so from that we could see that, the tilt effect of time peregrination into the future as we have trajectory towards, the classical mass worth. And that is what we have in the Einstein time slice. You understand? So Einstein said that it is not possible. He said it is not possible for us to have what is it called? Relativity of simultaneity. Relativity of simultaneity is that, we can't have a global now. What that means is that we can't have a global now. So basically, in this video, we're going to see how we can actually get global now here. So now let's move on. So now, the thing, we can now see the effect, we can see the time slice by applying formula of everything. It's that electron's worth. There is this suspension because the value that we're going to get is going to be this particular value that we have around the curvature, which is 5.7 times 10 raised to power 48. We have this value at classical level, and then we understand how the linear trajectory would be. It's going to be diagonal because it will emerge from the Big Bang singularity. And so that is why I have this linear trajectory, the linear trajectory, diagonal trajectory, where I have 5.7 times 10 raised to power 32. Now the 32 is the point where that 4m's worth, which is the weak conveying force, that is where it is being suspended to the strong conveying force. Now this capital that is the strong conveying force. Now the 4m, you can see that in form of the big blue circle at the edge of that equilateral triangle. So now it is being suspended at 30 seconds, and that shows that it is not at the curvature of time, and so it's a suspension. So by having that, we know that that suspension is an action of time, and so it must have a reaction of energy, because there is this, inverse relationship between time and energy. So by having equal reaction, and then we end up by having this, which is, that inverse diagonal trajectory in red, where its own value is 5.7 times 10 raised to power minus 32. So we now have that like that. But now the question is, how can we then close such as to have the baseline of the equilateral triangle for us to completely model the equilateral triangle of the past or of the expanding cosmological space? Then for us to do that, we need to annihilate the suspended zeros. We're going to manually annihilate the suspended zero, but basically the annihilation is going to be spontaneous, because don't forget that when you are moving against gravitational field, you will feel the exertion of that gravitational force on you, and that is why we could have this where you have acquired the potential, where you have acquired the necessary energy potential. Then if you should drop from that height, you are going to have free fall. So now that free fall is going to be spontaneous, and that that by having free fall, that is the gravitational phase. And what that is actually telling us is that the free fall that we have, that is the classical gravitational phase. There is quantum gravitational phase, which I will later tell us as we progress. So, but now we will do it manually. Then we annihilate the zeros. And for us to annihilate the zeros, we will take the base value, which is 9,109. So there is no point in that suspension. And with that, we know the suspension is at classical level. So now when we take that value, 9,109, we put it over the 10 raised to power 32, which is the power of the suspension. It's only the, we're trying to annihilate through the zeros, only the zeros. So we are less concerned about the value out before the zeros. So now, by doing that, we see when we extend that fraction, we're going to have 9.109 times 1 raised to power 10 raised to minus 32. 10 raised to power minus 32. So when we finally, solve that, we're going to have 9.109 times 10 raised to power minus 32, which is the value of the quantum mass worth that we get. So now the thing is this: if we should use that value, the decayed value, that value is being decayed by the worth of -1. If we should use that inside the formula, because the formula of everything is a formula that fits back on itself. And what that means is that we can actually use an input to generate an output, and then use the generated output as input. Use that decayed value in the formula. It will also decay the classical mass worth by almost 2 billion worth. And so we can call that, a butterfly effect, because the tiny decay of -1 has resulted to almost about 2 billion. With this, we can actually track the, relationship, the decaying relationship from quantum level to classical level and all that. So basically, right now, we can say in that sense we have a kind of causal effect, like, the tiny cause of decay at quantum level has resulted to 2 billion, almost 2 billion. Let us pay attention to this. Please pay attention to this. So now that we have this value, and so we have this equilateral triangle, then we now realize something. The trajectory of time being vertical means that it is instant. But basically, if something is said to be instant, it has to be snappy. So we shouldn't have this elongation, but by that, relationship between, by that, relativistic scaling of time to energy, even at vertical phase of time peregrination, we still have energy elongating time. And so we have this elongation. And by the virtue of that elongation, even though the time trajectory is instant by being vertical, then it means that we have a field right there, and I call it relative field. So it's a kind of field that is static and undulating. So you can see it is static but yet undulating. It sounds somehow. Yes, but now we see that the trajectory of time is actually longer than travels beyond the time energy constraint to connect to the quantum mass of positron in this case. And by connecting to that, it means that we have moved into the complex system. So basically, there is this connection between a substrate dimension. Now, when you look at this diagram, this is a 2D. It's a plane. It's a 2D diagram. Now, for time to actually travel out of the energy's curvature, then there must be a kind of alignment that will go into the higher dimension. So in this case, the higher dimension is 3D. That we will have at energy with of discrete nature of energy for us to have standing wave. Now, standing wave is also a kind of wave that it's a wave that is static, that doesn't have direction. And it's only by standing wave that we can have that projection into the 3D, such that we now get connected to the electron of the 3D, and by that connection, by the virtue of that connection, it will instantly be converted to positron. Now, before that conversion to positron, if you look at what we have here, 5.7 times 10 raised to power minus 32, smaller to the worth of electron. So definitely we're going to have electron in this equilateral triangle that I have at the bottom here. I have this equilateral triangle there for you to know that we usually have a compacted equilateral triangle, and that compacted equilateral triangle will allow us to have a constantly accelerating momentum. By having a constantly accelerating momentum, that will actually even out the discrete nature of energy, such that energy will be smooth at that tiny trajectory of time. That tiny trajectory of time, such that it will be equal to the smooth flow of time. You understand? And as a result of that, we would have alignment to the curvature of energy to have that standing wave. And that will get us connected to the higher dimension. And so we then connect to that positron that will be instantly converted to positron. And that positron will be injected into the system. Now, don't forget that the moment that we're going to have electron right here at the point of contact to the electrons of the higher dimension, then the electron that was initially that we initially have right at the classical level will be converted to positron. So basically, the essence of just having that positron, which is a kind of a hole that will serve as a positive charge at that quantum level, is for it to connect to that missing piece, which is the positron. And that positron is not its own positron. It's an electron of another higher dimension that is instantly converted to positron, which will now be injected into the system. So by not being its own positron, then there may not be a complete contact between the two for us to have, both of them being consumed by such radiation or by such interaction, you understand? So definitely when we look at the trajectory inside the black hole, we have it to be positive because we have it being continuously increased, and it is positive, unlike what we have in the cosmological space of the expanding universe, where we have the trajectory to be towards negative, which shows that it decays value. And it is for that reason that we do not have the real quantum mass worth right inside the equilateral triangle, which is an inverse of what we have in the classical realm. In the classical realm, I mean where we have the horizontal line to the top, that is the classical realm. So the horizontal line to the bottom, that is the quantum. We have real classical mass. You can see that, you see where it is located. But in the quantum, there is nothing of such. We now have the real mass outside the time energy wave model. So it means that at quantum level, we constantly have the decaying mechanism that generates radiation, which supports the mass convergence at classical level. So that is the system of the universe. So now, for us to now talk about what causation is in this diagram, we know that the moment energy is discrete, the trajectory of energy will be shorter to the trajectory of time, because time is continuous, orchestrated by the mass convergence that we have, because mass convergence will be smooth, and that we will have reaction to be energy would allow us to have the smooth trajectory of time. And so it seems as if support that mass convergence in order to expand the universe continuously. So we see that if we were to say what is causing the expansion, energy and mass, they are the factors of expanding the universe. So basically we see that energy is traveling inversely to time trajectory. That is a kind of expansion already. And then by the virtue of mass convergence, then we know that that will as well result to expansion. So now, energy being discrete will make the trajectory of energy to be shorter to that of the time. And as a result of that, we're going to have this time slice to be tilted towards the past, because basically we're having a momentum away from the real classical mass. So you can see that we have energy density away from the real mass. And as a result of that, then we're going to have that tilt effect of time peregrination towards the past. And that is the line, the dashed line that we have. By having that, we know that it is the event in such tilted time peregrination will be sequential. So the sequential progression will be from the quantum to the classical. So basically it is ideal in that sense, and so we could say we have causal phenomenon. The causal phenomenon that we have, the tiny shift that we have is the virtue of relativity, because energy is inversely related to time. and that we show in the suspension that we have as a tiny difference between the energy's trajectory to time's trajectory. So now by having that, we can say yes, we really have a causation, because now we can say in the expanding phase, we can genuinely say that, well, causation must precede effect. Cause must precede effect. So we have the missing piece of electron, which is positron. And so that is injected into the system for us to have momentum into the black hole. So at the present phase, the energy is low. So external energy must be injected for us to have energized phase into the black hole. Now in the black hole, we can see that the momentum, the trajectory of time in that, tracing that equilibrium continuously or constantly increasing, and with that we can say or get to have access to positron in our expanding cosmological space, because in that expanding cosmological space, why positron is operational in the black hole. So right now, what will now be the effect of that on time slice? Now we can see the time slice that we have. It's actually pointing back to the energy density of the classical realm. Why do we have it to be like that? By energizing energy at quantum level, then energy is ahead of time. Now in the cosmological space, in the past, we under the time slice, can you see what I have right there? Let me increase the size. Now you see that here I have time is ahead of energy. Where we have sequential flow of event, we have it because time is ahead of energy. But now in the black phase, in the black hole phase, we have energy being ahead of time. Now what is the effect of the we have time ahead of energy? We usually have convergence of genuine mass. So now the implication of that is that would cause the classical mass to be decayed, and basically in that sense we can say causation is ahead of effect, which shouldn't be. Causation have in the black hole is that causation is ahead of effect. So basically there is this issue of future curvature, like curvature affecting the future curvature, future causation affecting there is this argument about having this kind of phenomenon, but based on this formula of having this phenomenon. So that is another thing we need to know. There is possibility of having this phenomenon. Now, the elongation of energy in this vertical trajectory of time. The implication of it is that what we can call instant trajectory or instant transmission of information might not really be instant, and that will be related to 99999 in 12 places percent empty. So if atom could not be absolutely empty, then it means that there is this tiny imbalance of time to be from the past to the future, because the flow of time is actually from this classical realm down to the quantum realm, and that is from the past to the future. Now when you see the horizontal line, which is the trajectory of energy, so horizontal line, the dashed horizontal line represents the infinite trajectory of energy, while the vertical line represents the instant trajectory of time. So where we have the intersection of the two, that is the equilibrium that the classical mass world must actually be relocated to for us to have the conscious sensation. And our consciousness is actually, the conscious feeling is gotten at this present phase of time peregrination or at event horizon. Because the moment we get connected to the missing piece of electron, which is positron, and then we have the instant feedback of such connection as updated information for the classical mass, that is the sensation of being conscious. But that is the first phase, because when you get a particle, you'll be conscious of that. But internalization is the point where to the intersection of time and energy trajectory, and that will be right where this trajectory of black hole must have reached the core singularity of the black hole, and that internalization phase will give us subjective experience. And when we have subjective experience, that is when that what we are being conscious of is being thoroughly and permanently instantiated. So for instance, when the music is being played, you will be conscious of that music being played. But that is the first phase of consciousness. When that music is being played repeatedly, such that you are so accustomed to that music that you know it lyric by lyric, then it has become a subjective experience. It is now your personal reality, and then it will be difficult or hard for you to forget such a song. So now that is that about, though I didn't even intend to say anything about consciousness, but I just have to say it to explain this causation more. So basically, from what I've explained now, we can see what causation is, and that has made us to go so deeply into the fabric of universe. And so with that, we have gotten the reality of the whole thing. So there is possibility, because it is, I don't know if I should say it's a fundamental aspect or part of the fabric of the universe, you understand? So, but basically from what I've explained, I know we already know that causation is highly essential, and it is, the part of the fabric of the universe. Then another thing I want us to know is that this equilateral triangle in the past phase is being flipped in the future phase, which is in the black hole. So now what we have in the black hole is different from what we have in the expanding cosmological space. Now, right at the nucleus portion of the black hole, we have mass density. And then what we have in the Big Bang singularity is energy density. So black hole singularity is mass density. Big Bang singularity is energy density. So when something is being flipped, that flipped version is not going to be the original copy. It's not going to be original copy. So basically that, is now rooted in what I said earlier on, that if we're to dissect what the default status of time and the default status of energy, then we might say that time deals with precision while energy deals with, possibility of being biased. You understand? So definitely we're going to have authentic formation, and then we're going to have inferior formation, or we say we have fake. So we have original and fake. Then it is left for us to choose which one we want to we want to pick. So basically that is what we have right there, and I hope that explains causation. So now in the description section of this particular applications, I have link to my Amazon authors account. I have link to my social media. You can get connected to me on LinkedIn. You can get connected to me when you search for Shotade Olusegun. Shotade is Sotade, then Olusegun is Olusegun. So you can actually get connected to me by searching for my name. And then on YouTube, you can get connected to me at Shotade Olusegun altogether. On X, you can get to me at Shotade A1. Then on Instagram, you can get connected to me at Shorix Nonis, which is SHORIXNONI. So you can also get connected to me on TikTok at Shorix Noni. So now that is going to be where I will stop for today's live. So the subsequent video, I will be talking more on some tough. I'll be I'll be reviewing some other tough topics like that. Well, basically, let me quickly give you a disclaimer. This video is actually for educational purpose alone. So, and it's a review video of that video of Closer to Truth. You understand? So basically it is for educational purpose. You understand? So that is the disclaimer that I'll give. So thank you so much for your time. Remain blessed forever.